Good morning. Welcome to another session on environmental impact assessment.
Unit 5 Case Studies. Course outcome: describe the EA for various infrastructure projects. Learning outcome: explain the EA for water treatment plants. Specific outcomes: explain the impacts of wastewater treatment on the environment. So before going into the impacts, we will look at some of the basic definitions. Wastewater is water whose properties have been changed by domestic, industrial, agricultural or any other use, and water, which is generally called as sewage, discharged with it during a dry weather season, as well as the runoff and collected water, that is rainfall, from built up or paved areas due to rainfall. So sewage also includes the liquids discharged and collected from wastewater treatment and storage plants. Community water management, a division of water resource management, which comprises the sum of all the targeted environmental protection measures to supply communities, trade and industry with satisfactory drinking or industrial water, as well as disposal of domestic, commercial and industrial wastewater from these areas. So community water management, division of water resource management takes care of these things. Wastewater disposal, a division of the community water management, essentially comprises the collection, removal, treatment and disposal of wastewater. So generally accepted rules of the art comprise those rules which have been tested in practical application, such that the majority of the people working in this specialist field regard the processes, facilities, plans or operation methods in question as correct. So the technical nature of the rules may vary according to the requirements in individual countries. Right, so the rules and regulations vary slightly between country to country, but majority of the people working in that particular field, if they consider the processes, plans, facilities and operating methods to be correct, then it is accepted, right? The state of the art is the state of development of advanced processes, plant, facilities or operating methods guaranteeing the practical suitability of such technical measures. To determine the state of the art, an assessment must be made in particular of comparable processes, plants, facilities or operating methods which have been successfully tested in operation. The technical nature of the state of the art may vary according to the requirements in individual countries. So the problems with wastewater treatment: the worldwide industrial development of recent decades with its effects on the manufacture of goods and on the consumption pattern and health habits of the population has led to an appreciable increase in the volume of wastewater. In this respect, targeted wastewater disposal involving careful analysis and taking into account not only of the local conditions and options, but also of the environmental aspects of the relevant plan can bring about the necessary improvements. As a rule, these relate to measures not only in the fields of wastewater technology but also in the fields of law, administration, business management and organization. The necessary improvements should also aim to achieve reasonable representation for women as one of the target groups in the institutions and bodies responsible for wastewater disposal. Right, so it is not only dealing with wastewater. Here what we are saying is providing some improvements such that there is some representation for women, right, in institutions and bodies which are taking care of wastewater disposal. So this is the best way to guarantee that their legitimate interest in participating in the development and implementation of administrative, business and environmental monitoring regulations will be fulfilled or served. The controlled disposal of sewage and rainwater forms a vital part of the infrastructure of human settlements built on the principles of hygiene and hence is fundamental to efforts to improve the quality of life. Furthermore, it is an essential component of water quality management whose aim should be, so these are the main aims of water quality management. One is to maintain an ecological equilibrium of the bodies of water, and where it has been disturbed, we need to restore it. Second, to ensure a water supply of guaranteed quantity and quality for the general public as well as for trade and industry, with particular emphasis on long-term sustainability. Third, to enable all other water uses which serve both the well-being of the general public and the legitimate needs of individuals in the long term. Statistics show that in many countries there is a marked imbalance between water supply and wastewater disposal. This is because in countries in question, clear priority has been given to the matter of water supply without paying at least equal attention to the necessary development of wastewater disposal facilities. The same also applies to the relationship between water supply and wastewater disposal in commercial and industrial establishments. Right, so they give a lot of importance to fulfilling the water supply demand, but not on disposal facilities for wastewater. With this environmental brief, questions on municipal wastewater disposal also takes high priority. Questions on commercial and industrial wastewater disposal, in view of their complexity and scope, can only be dealt with selectively. right? So domestic wastewater treatment is relatively easier, but when you go to commercial and industrial wastewater treatment, it is more complex because the process is complex. Here it's only water that is coming from the kitchens or water that is coming from the latrines, but there it is manufacturing process which is generating a lot of wastewater. Stages of wastewater disposal. The area of municipal wastewater disposal may in particular comprise of the following stages. One is wastewater collection, second is removal, third is treatment, fourth is discharge. Excuse me. Fifth is disposal of fecal matter, and last one is sludge treatment. What is sludge? Sludge is actually the solid substance that is left behind after dewatering of the liquid substance, right? From the wastewater, if you dewater the liquid substances, you will get some solid matter, which is nothing but sludge. So generally what they do is the sludge will be dumped on open lands for natural decaying and drying, right? So the disposal stages mentioned may refer to both the sewage and to the rainwater. In this respect, one should not forget the percolating water, which includes, example, groundwater, which penetrates sewers through leaks, or drainage water, which results from groundwater lowering and is removed via drainage network. So we need to focus on this aspect also, right? That is uh, percolating of water, right? Groundwater um, through leaks, right? And also the drainage water. Generally, what happens is that sometimes this can also happen. But thing is, like, the drainage water may percolate slowly into the ground surface and reach the groundwater, and groundwater may get contaminated. That is also possible. Stages of groundwater disposal. So in the individual stages, the following wastewater process take place. One is wastewater collection. So whatever we have seen in the last few slides, a little bit detailed explanation of that. Collection of wastewater source using connection down and soil pipes, as well as wastewater collection pits, cesspits, latrines, etc. Wastewater removal, that is conveying the wastewater through sewers. In case of rainwater, it is through open channels, right? In case of sewers, it is closed sewers using separate, combined, or sewage only systems. Application, that is treatment, involves application of physical, biological, both aerobic as well as anaerobic. Aerobic is using bacteria which take up oxygen. Anaerobic is bacteria which do not need oxygen, right? They thrive in the absence of oxygen. And chemical process with the aim of minimizing the substances contained in the wastewater which are harmful to the environment and in particular to water, or of reducing their harmful effect to the necessary degree. Wastewater discharge, return the wastewater to the natural water cycle, that is using clarification basin, overflows for counter overflow basins in the combined system, rainfall overflows in separate systems, or effluent channels in sewage treatment works. That is, we are discharging the wastewater, right, properly after treatment. So what they do is they bring it back into the water cycle, right? So generally it is not good to dump them again into the water bodies, provided if the treatment has been done properly and water quality is quite good. You can again dump it into some dump the treated wastewater into some lakes, but generally they use it for some other purpose like gardening, sometimes in the farms. Sludge treatment, processing sludge for recycling or disposal. So the environmental impact of the disposal stages described should first be considered individually in order to assess their importance. Then an integrated assessment taking into account of any significant interaction should be carried out for the project. In case of commercial and industrial wastewater disposal, one should proceed in a similar way on the basis of the above mentioned disposal stages for both directly discharging and indirectly discharging wastewater producers. However, there is one further decisive disposal stage which must be considered first, namely the stage involving avoidance or reduction of the wastewater, taking into account of the quantity as well as the quality, pollutant loading, right? So in this respect, questions of material input of production as well as that of production itself, that is the process itself, are particularly important, right? So first comes avoidance or reduction of the wastewater, then comes the treatment process. To gain a full understanding of the wastewater disposal project, it is vital to determine the underlying conditions and constraints of the project against the background of its ecological and economic effects, right? So the project description is based on the following criteria: previous history of the plan, water legislation standards, current wastewater situation, actual condition of the receiving bodies of water, target condition of the receiving bodies of water, previously established wastewater objectives, for example, based on the existing general sewage plans or other evidence of demand, incorporation into regional, national, and countryside planning objectives, and also the regional or supra regional disposal system, reasons for choice of plant works and its main components, right? Alternatives as well as baseline state, right? So, a water, a wastewater treatment project, what to say, plant or project will have all this data, right? Further components on the environmental impact assessment of wastewater disposal project are descriptions of the location finding process for relevant alternatives, including any necessary socio-economic analysis of sex and group, specific questions on the population settled in the surrounding area or area covered by the wastewater treatment works in question, the location comparison and results, relevant works and the failure risks, factors of the project adverse to the environment, and those plants or plant components which should eventually form the object of an environmental impact survey. So we should not look at only that the quality of water and the process facilities and so on. We should also look at the people who are living around that particular plant and compare the different locations, right? The risks that are involved, the factors that are involved in the project, right, which will have an adverse effect on the environment also should be considered. Domestic sewage mainly comprises lavatory wastewater, kitchen wastewater, wastewater from baths or showers, cleaning wastewater from house cleaning. It therefore has a varied structure, but as a rule, its quality is not such that the existence, operation, and safety of the sewage plants or the health of the operating personnel would be endangered. Moreover, it lacks properties which could result in adverse changes to the environment, provided the sewage works are designed correctly, the bodies of the water managed appropriately, and the sewage sludges produced are disposed of and recycled properly. So, the domestic sewage is actually really not a big threat to the environment. However, here one should note that special attention should be paid to the correct operation of sewage plants, and hence water conservation. If the volume of wastewater is subject to large variations, right, there are sudden loads or temporary and sometimes complete absence of wastewater, meaning when you're running the plant, you need to take care of the different loading conditions in terms of pollutant loading or the quantity of water. So everything has to be done properly. Then the domestic sewage plants will work well and you can treat the water easily. This applies particularly to hotels, highway service areas, campsites, convalescence homes, and similar installations with individual drainage. Special planning and operating methods are required here to prevent avoidable pollution of bodies of water. The direct discharge of commercial or industrial wastewater is safe if, as a result, the health of the staff employed in public sewage works is not adversely affected. The state and operation of the public sewage works are not adversely affected. The bodies of water which take the wastewater from the public sewage cannot be polluted beyond the permitted level or otherwise adversely affected. No lasting odor nuisance, that is smell, occurring from the sewage works. The sludge treatment, sludge recycling, and sludge disposal are not seriously hindered. If adverse effects of the type described above are anticipated, then the discharge of the wastewater into public sewage works should be conditional on pre-treatment at the point of production or other suitable measures. So, as I said, if you are disposing of the industrial wastewater, it should satisfy these conditions, meaning it should not cause any health impacts on the people who are working on the sewage plants or on the public or on the water bodies. There should be no smell. Sludge treatment should be properly done. So in that case, then you can discharge the commercial or industrial wastewater into some water bodies. Otherwise, you need to treat it properly before it is sent outside. Safety is generally assured if the figures, there are some conditions, like we will not be looking at those conditions here. Substances which block the sewage network from poisonous, foul smelling, or explosive vapors and gases or attack buildings and building materials to a significant degree must not be discharged into public sewage works. If adverse effects of the type described above are anticipated, then the discharging of the wastewater into a public sewage work should be conditional on pre-treatment at the point of production or other suitable measures. So it is actually not only discharging of the treated wastewater into some water bodies. Here what they are mainly speaking about is discharging them into the public sewers. Right? Sewers actually finally they go and meet into some water body, right? So as what I told in the last few slides is directly discharging them into water bodies, but here what they are saying is discharging them into public sewers, which eventually go and meet some lakes or rivers or seas. Substances which block the sewerage network, right? Uh, Anyway, it's the same thing, right? So you should not have any poisonous, foul-smelling, explosive vapors and gases dumped into the public sewage works. Because of their geographical and physical impact, supplies and disposal projects must stand in clear and plausible relationship with other environmental and geographical areas. This is particularly true for wastewater disposal projects, bearing in mind the potential danger posed by the domestic, commercial, and industrial wastewater to be disposed of. Areas which are affected by the wastewater treatment or wastewater discharge projects, such that this may lead to conflict of use and interactive effects include in particular the following: bodies of water, right? Surface water, groundwater should not be affected. Water source management, hydraulic engineering, soil, agriculture, forestry, air pollution. Air pollution because you leave the sludge for drying outside, and after it gets dried off, there's a possibility that due to wind effect they may be blown off. The solid matter particulates, they can travel somewhere and cause air pollution. Water production, water supply, waste management, waste disposal, nature conservation, countryside preservation, recreational resources, urban or community planning, industrial development, monuments and heritage should not be affected. Traffic planning should not be affected. Existing or future regional planning should not be hindered. Land use and development planning, activity planning, distance problems in existing and planned residential areas should not be affected. Right? Availability of land and soil. So if conflicts do occur, the options must be weighed up, right? So meaning we need to look at some other options and give importance to that. The standard against which they are judged is not the status quo, that is the structures and services existing prior to the execution of the wastewater disposal project, but rather the development potential of the area in question. The criteria is thus the capacity, not the present performance. This approach also stresses the importance of identifying and assessing the soil potential, biotope potential, and hydrogeological potentials in terms of the quantity as well as quality. Right? So you should not affect the soil. For example, the sludge can affect the soil, and soil can get degraded. Right? So that should not happen. And possible. And as I said, the water should not penetrate into the groundwater and contaminate the aquifers which are below the surface of the land. So if that happens, then there is no possibility of having drinking water in that particular location. Adjustment, elevation, and compensatory measures may provide crucial help in arriving at the environmentally ideal overall solution. Thank you.
Thus, we come to the end of this session. Thank you for your participation. Looking forward to meeting you in the next session.